Okay, in this video we're going to look at quadratic functions. So our parabolas, on the left there we have what's called vertex form, y equals a times the quantity x minus h squared plus k. H comma k is going to be the vertex. If your a is greater than 0, you're going to open up, and if you open up you're going to have a minimum at the vertex. If your a is less than 0, then your parabola is going to open down and your parabola is going to have a maximum. The symmetry for a parabola is going to be the x coordinate of the vertex, so it'll be a vertical line, x equals the x coordinate of the vertex, or x equals h. Okay, now vertex form and standard form, sometimes the books will refer to vertex form as the quote-unquote standard form. When we think of standard form, usually we think of y equals ax squared plus bx plus c. The vertex there is going to be for in standard form, vertex is going to be negative b over 2a, and then if we call y f of x, then the y coordinate is going to be f of negative b over 2a. Now for the x as a symmetry, then the x would be equal to negative b over 2a. So we'd have to figure out what that is. The rest of it's going to be the same. A greater than 0 opens up, a less than 0 opens down. So we'll want to find the vertex, and then direction of opening, we'll put the axis of symmetry in, and then we'll also want to get some intercepts. So if we want to find the x-intercepts, you're going to replace y with 0 and then solve for x, and then if you want to find the y-intercept, you're going to replace x with 0 and then solve for x. So if we take a look at something generically, like we start in standard form, okay, and then how do we get to the vertex form? So we're going to start with y equals ax squared plus bx plus c. The first thing we're going to do is we're going to identify our ABCs, okay, and we're going to move c. So what we're going to do is we're going to complete the square. We subtract c from both sides. The next thing we're going to do is we're going to divide by a. So we divide by a. So we have y minus c over a is equal to x squared plus b over ax. Okay, the next thing we're going to do is we're going to add the quantity b over 2a squared to both sides. So very similar to completing the square, solving by completing the square. So y minus c over a plus b squared over 4a squared is equal to x squared plus b over a x plus b over 2a quantity squared. Okay. Step 4, we're going to go ahead and factor the right-hand side. And we'll leave the left-hand side alone. Okay, so then we're going to have x squared plus b over 2a quantity squared. And then step 5, we're going to go ahead and solve for y. So y is going to equal to a times x plus b over 2a quantity squared plus c, a, and then plus b squared over 4a when we go ahead and solve for y. Sorry, I had to fix an error there. So we would subtract b squared over 4a squared from both sides. Then we'd multiply both sides by a, so I shouldn't have an a with a c. When I multiply by a, that'll absorb one of the a's on the 4a squared in the denominator. And then finally we'll add c. So we don't really need to know what this is, but now the opposite of b over 2a is negative b over 2a, so that's the x coordinate of the vertex. So we're going to look at a couple examples. I think we're going to do 3. We're going to go ahead and write the equation from standard form to vertex form. We'll find the vertex, the axis of symmetry, the x and y intercepts, and then we'll use all that to actually graph the parabola. Okay, so the first thing we're going to do is we're going to write down all the steps again, so we'll have that on the screen while we work through this. So we're going to look at writing in vertex form. We're going to identify if it's a maximum or minimum, so we need to know if the parabola is opening up or down. And then we'll also find the intercepts there, okay? So the first graph we're going to look at is f of x equals negative 2x squared plus 4x and minus 5. So we're going to follow the steps, identify our ABCs. We're going to add 5 to both sides to move the c. Okay. Then we're going to divide by a. The a is negative 2, so we have f of x plus 5 over negative 2, and that's going to be equal to x squared minus 2x. Now we're going to add b over 2a squared to both sides, so we can complete the square on the left-hand side. So when we do that, that's going to end up being 1, so we're going to add 1 to both sides. And then we'll go ahead and just rewrite most of the left-hand side. The right-hand side will factor into x minus 1 quantity squared. The plus 1 right here, well, let's do the highlighter. That plus 1 right here, we've moved it. We're going to move it over, so we're going to go ahead and subtract it. So we're being a little bit efficient here. Then the next thing we're going to do is we're going to multiply by negative 2. Okay, and then so that'll make that a positive 2, and then we're going to subtract 5, so that'll make it a negative 3 when we solve for y or f of x here. Okay, so your vertex is going to be opposite of what's inside here, so that's going to be 1 and then negative 3. And because the a here is negative 2, that says we're going to open down, so this is going to be a maximum. The one other thing here is, I don't have it, I don't think I listed it here, but your axis of symmetry is going to be the x-coordinate of the vertex, x equals 1. Okay? The next thing we need to do is we need to find our intercepts. So we'll find the x-intercept. That means y is equal to 0. So we'll go ahead and solve the equation. So we're going to isolate the x minus 1 squared, so we're going to plus 3, and then divide by negative 2. Now what's going to happen is we're going to take a square root of a negative, so that's going to give us a complex number, and because we're graphing on the xy plane, we don't have x-intercepts, so we have complex roots, and so we have no x-intercepts to graph there, and that can happen sometimes. Now if we want to find the y-intercept, that's easier, that's x equals 0, so you can plug it into the vertex form or the original equation, so the y-intercept is going to be 0 and minus 5. So what we're going to do is we're going to grab all this stuff, we're going to go on to the next screen here, and we're going to use all that information to actually graph the parabola. So f of x is equal to negative 2 times the quantity x minus 1 squared minus 3. The vertex is going to be 1 minus 3, excuse me. Your y-intercept is 0 and minus 5. We're going to say no x-intercepts, okay. Alright. So we're going to go ahead and plot the vertex 1 and minus 3. Okay. And then also our y-intercept of 0 and negative 5. Okay, so we have all that stuff on there. So what else do we need? Oh, I need to hit play. There we go. So our axis of symmetry is going to be x equals 1. And we can put that in as a dashed line. And because it's the axis of symmetry, now we have the y-intercept, and so its mirror image is going to be right there. So we get that point for free when we're graphing our parabola. And usually we were like 5 points would be nice. So I'm just going to pick another value. So we got 1 for 2. So now we're going to do 1 for 3. So I'm going to plug 3 in. And so we'll go ahead and work that out. And we get, let's see what we end up getting. We get minus 8. I'm sorry, not minus 8, minus 11, excuse me. And so that's going to be a little bit further off than what we got going on there. That's okay, but we do have our parabola here, opening down, and it does have a maximum at its vertex. Okay? And you see that it never touches that x-axis anywhere, and that's why we have those complex roots. So it is entirely below the x-axis and opening down. The other scenario is it's entirely above the x-axis and opening up, you would not have any x-intercepts. Okay, so we're going to take a look at another one, same process. So here's the function. We'll write down all the steps for putting that in vertex form, identify your ABCs. Okay, so we do that. We'll go ahead and move c over. So we're going to subtract 3 from both sides. 2x squared minus 8x on the other side. Divide everything by 2. Divide by a. So we get x squared minus 4x. And then we're going to add b over 2a quantity squared to both sides. That's going to be negative 8 over 2 times 2 squared. And that reduces down to negative 2 squared, which will be 4. So we're going to add 4 to both sides. Okay, so we have gx minus 3 over 2 equals x minus 2 quantity squared, and then I went ahead and subtracted that 4 right there to save a little bit of time here. So we've completed the square. Now we just need to solve for g of x or y, so we're going to multiply both sides by 2 and then add 3. So g of x is going to be equal to 2 times x minus 2 squared minus 8, and then we'll add 3 to both sides. Okay, so we get 2 times the quantity x minus 2 squared, and then minus 5. So that gives us our vertex of 2 and minus 5. And this is, because our a is positive, this is going to open up, so we're going to have a minimum. We also have an axis of symmetry, AOS, x equals 2. Alright, let's go get our x-intercepts, so that means the y is equal to 0. So 0 is equal to 2 times x minus 2 squared minus 5. So we're going to go ahead and isolate the x minus 2. So we're going to add 5 and then divide by 2. And it's going to be equal to x minus 2 squared. Take the square root of both sides and don't forget your plus or minus. And you will also add 2 to both sides to isolate. So you'll have the square root with plus and minus, 5 over 2, and that's going to be equal to x minus 2. And then we'll go ahead and add the 2 there, so that's where that 2 came from. Okay, and then I need to put those in my calculator because we want to graph them, so we want to get a decimal for those two values. So plugging that into my calculator, I get about 3.6, and then I get about 0.4. For your y-intercepts, we'll go ahead and plug 0 into. You can either use the vertex form or the original form. You're going to get the same answer. You can go ahead and do the original because it's easy. So that's going to be it's going to be just 3 because the 2x squared and the minus 8x, those are going to be 0. So that's your y-intercept. So we're going to grab all that stuff and we're going to move on to the graph. So we'll write down our equation. There it is, and the vertex, and your y-intercept, your two x-intercepts as ordered pairs, and your axis of symmetry is x equals 2. Okay, so draw that. Put in your axis of symmetry at 2 as a dotted line. We'll go ahead and put in our vertex at 2 and minus 5. There it is. We got a y-intercept of 0 and 3, so we'll go ahead and put that in there too. And by symmetry, this is 2, well, it's not bright and white because we can't see that. So this is 2 units away, so then we'll have its mirror image 2 units in the other direction away. We also have our x-intercepts, and I'm also going to pick in. I'm going to also put in 1 there, so I'm going to go a little overboard here and have 7 points here. So when I plug in 1, I get minus 3. So then the mirror image is going to be there. And then we can also put in the x-intercepts there. Okay, and so we get a nice parabola with a minimum at 2 and negative 5. Okay. And so that's pretty much it. That's graphing in vertex form, writing the equation in vertex form. But we'll do one more, so we say we've done one with a fraction. So we're going to do one where we get a fraction, okay? Alright, so same thing as before, identify your ABCs, move C, divide by A, add B over 2A squared to both sides, factor, and then solve for Y. So same process as the other ones. So we'll identify our ABCs. We're going to add 4 to both sides. And then we're going to divide by 2. And notice I don't really do anything with it. I just write divide by 2 over on the left-hand side. I don't try to work it out, because I'm going to undo it anyways in a minute. Okay, so x squared minus 7 halves is on the right-hand side. We're going to figure out what b over 2a squared is. So that's going to be negative 7 over 2 times 2 squared. So that's going to be 49 over 16. So we're going to add that to both sides of the equation. Okay. All right, so we have h of x plus 4 over 2 equals x minus 7 over 4 quantity squared. That's what happens after we factor it. Now, whenever you find the b over 2a, that's always what it's going to factor into. So that's the minus 7 over 4. So that's kind of our shortcut for the completing the square. We'll go ahead and also subtract the 49 over 16 from both sides of the equation there. And then we'll multiply both sides by 2. So we're solving for the y, or in this case the hx. So 2 times x minus 7 over 4 quantity squared minus 49 over 8. And then finally we'll subtract 4 from both sides. And 4 is the same thing as 32 over 8, but we wanted a common denominator, so that's why we chose to do 32 over 8. Alright, so h of x is equal to 2 times the quantity x minus 7 over 4 squared. And then minus 81 over 8. And we might elect to change things into decimals instead of the fractions, because it'll probably be a little easier. Okay, so our vertex is going to be 7 over 4 and negative 81 over 8, which is 1.75 and negative 10.125. Okay, so that'll be a little bit easier. We can go ahead and sneak in our axis of symmetry also. So AOS for axis of symmetry. If I can write it correctly, AOS, x is equal to, what did we say it was? 175, okay? All right, so let's go get our x and y intercepts. So we'll let y equal 0. So we have 2x squared minus 7x minus 4 is equal to 0. This one I can end up factoring. I could use the square root property like I did the other ones and use that vertex form, but I'm going to go ahead and factor this one because I noticed it factored. You don't have to. You'll get the same answer as if you do the other method. Okay, so this gives us x is equal to negative 1/2, or x is 4. For the y-intercept, it means the x is equal to 0, and so h of 0 is equal to negative 4. Okay, so we got our vertex, axis of symmetry, x and y intercepts. So we're ready to go. So let's go graph this last one with fractions, or in this case we decided to do decimals. So write down all the information that we have. It is going to be a minimum because the a is positive, so the minimum at your vertex. Okay, so vertex is going to be 175 and then negative 10, 125. Okay, your y-intercept, 0 and negative 4, x-intercepts, or minus 1/2, 0, and 4, 0. Axis of symmetry was x equals 175. Okay, so we'll go ahead and do our best guesstimate. There's about 175. And then we can go ahead and put in our vertex. So I'll have to count all the way down to probably negative 10 or 11. Okay, so that's our best guesstimate. We do have a y-intercept 0 and 4, so roughly this distance here will be over here, so somewhere around there for the other point, the mirror image. I also put in my x-intercepts, and then that's that mirror image I was referring to. I think they're fairly close, so because it's not not an integer. It's a little bit harder to graph. And then there's your parabola. You got your minimum there, and so they're all going to work out pretty similarly. If they give you it in standard form, then you gotta, and they want the vertex form. That's how you convert it to vertex form, and then from there you can find your x and y intercepts and graph it from there. Takes a couple of times of working through to get the hang of it.